Hello everyone. So today we are going to see about the chi-square test and some problems. So what is chi-square test? The chi-square test is the statistical procedure for determining the difference between observed and expected data. So some of the data they have given and we have to find the expected something or different. So what is the difference between them? That analysis is called the chi-square test. Okay. So that this test can also be used to determine whether it correlate the categories variable in our data. That is, is there any significant relation between them or not? So this is a correlation. This is a determination. This test is the evaluation part of the data. What is our expected? What is our observation? So this is a main thing. Next, chi-square test definition. So chi-square test is a statistical test that is used to compare observed and expected result. The goal of this test is to identify whether the disparity between actual and predicted data is due to change of or the link between the variables under consideration. As a result, the chi-square test is an ideal choice for aiding in our understanding and interpretation of the connection between our two categorical variables. Okay. So next, the formula of this chi-square test is the symbol is called chi-square, which is equal to summation of y minus ei the whole square dividing by y. Y is nothing but the observed values, ei is expected values, and c is the degrees of freedom. What is the degrees of freedom? That is a c. So the degrees of freedom of the statistical calculation represent the number of variables that can verify in the calculation. The observed values, how many values are given. So that is called the n, and n minus 1 is the degrees of freedom. Otherwise, if the category are the two categories, so the degrees of freedom will be changed as r minus 1 in s minus 1 or c minus 1. R is the row wise and c is the column wise. So that will be changed. This is a first type. So chi-square test for population variance. So this is a basic test for the test of variance. So let us assume x1, x2, etc. xn be the random sample from the normal population with variance sigma square. And this is the null hypothesis sigma square is equal to sigma naught square. Then the least statistic is the chi-square is equal to summation I is equal to 1 to n xi minus x bar the whole square dividing by sigma naught with the n minus 1 degrees of freedom. So second one is chi-square test to test the goodness of fit. So here they have given some observed data, and for that we have to calculate the expected frequency, and this number of the total number of frequency and the total number of observation, it gives a same number, that is total population. And the formula of this is equal to chi-square is equal to y minus ei the whole square dividing by ea, and this variance the degrees of freedom is n minus 1. So now we have to check some problems under this explanation, that is this goodness of fit. So the first problem, the theory predicts that the proportion of an object available in four groups A, B, C, D should be 9 is to 3 is to 3 is to 1 in an experiment among 1600 items. Of this object, the number is of the form groups were 882, 313, and 287 and 118. So using chi-square test to verify whether the experimental result support the theory or not. So some of the test they have divided the proportion as a 4 category, and the proportion of that category is 9 is to 3 is to 3 is to 1. And the observed values of these items are 882, 313, 287 and 118. So expected value and the observed value is there is any relation between them or not. We have to check this result. So okay. So now our hypothesis is the experimental value supports the theory. So that is our null hypothesis. Here the observed value is 882, 313, 287 and 118. So sum of this gives 1600 and the expected frequency ratio is 9 is to 3 is to 3 is to 1. So now we have to find the expected value for the given observed values. So how to calculate the expected means this is the formula and for observed values 882 the ratio of this is 9 times out of 16. The total of this total of ratios 9 is to 3 is to 3 is to 1 means 9 plus 1 10 16. So out of 16 we have given a 9 times importance for the first value and this is a for single and we have the 1600 items. So the expected for the first item 882 is equal to 9 by 16 into 1600. The value is 900. You will calculate this value using the calculator. And 313, the share of this is equal to 3 times. So 3 dividing by 16 into 1600, it gives a 300. And the 287, for this, the ratio of this is equal to 3 times. So 3 dividing by 16 into 1600, that gives a 300. And the last one is a 1 time. So 1 out of 16 into 1600, it gives a 100. So now we have to find OI minus EI. That is observed value subtract by the expected value. And it gives the square of that. The next column is the square of the calc- um, calculated what we have y minus ei and then y minus ei the whole square dividing by ei, that is the corresponding value is divided by the corresponding expected value, that is 324 dividing by 900, it gives 0.36. So like that we have to calculate all the values and the sum of this gives 4.73. So this called chi-square calculated value. Okay, so how to calculate the degrees of freedom is here. There are 4 values. So n is 4, n minus 1 is equal to 3. So degrees of freedom is equal to 3. So we have checked the table with the 5% level of significance, or you can check with the 1% level of significance. So generally we take a 95% level of confidence. Here, so 95 means 5% level of significance. We using the table value, they have to check, we have to check in degrees of freedom 3 and the 5% level, the table value is equal to 7.85. So here the calculator value is 4.73 and the table value is 7.85 and the calculated value is lesser than the table value. So our hypothesis is accepted. So accepted means there is no significant. So there is no significant. Okay, clear? Shall we move on to the next problem? So this is a second problem. 5 coins are tossed 320 times. The number of hits observed is given below. Examine whether the coin is unbiased or not. They have given some number of hits for the 5 coins. So what are all the possibilities of hits? 5 coins. If I toss a coin, 5 coins at a stretch, there is no head faced or 1 head faced, 2 head faced, 3 head faced, 4 head faced, and 5 head. These are all the only possibilities. So that is the first one, number of heads. And the corresponding frequency means 15 times out of 320 times, 15 times I got no head. That is 15 times all the 5 coins faced tail only. And 45 times only 1 head shows and 85 times 2 heads shows, 95 times 3 heads. So like that the frequency are given. Okay, the problem, can you understand the problem clearly? Now our hypothesis is the coins are biased or not. We have to check that. That is our null hypothesis. Okay. So here we have to calculate the expected value by the normal distribution because this problem under the category of coin tossing problem. If a coin tosses problem comes under the binomial distribution, the probability of getting binomial distribution is NCR n CR into P power R into Q power n minus R. Okay, Q power n minus R. This is the probability of getting, and this is the probability of, what is this? Probability of random variable x is equal to R. This is for 1. We get n time means we have to multiply this is equal to n times. Here n is equal to 320. So I multiply this 320, and how many coins are tossed? This n is nothing but 5. Okay, so this is 5. And first one is we faced a zero head. So no head. No head means 5C0. That is R is equal to, R takes the value sample space. R takes the value 0, 1, etc. up to 5. So this R has changed. So substituting these values, and this is the probability of coin tossing. The probability of getting head is equal to 1 by 2, and the failure, that is Q, is equal to 1 by 2. So the value of P is equal to 1 by 2 and Q is equal to 1 by 2. So substituting these values into here and calculating this, we know 5C0 value is 1. Otherwise, you can, using your calculator, you have to find the value for 5C0 using the fifth key. Okay, and the calculating this is equal to, this gives 10. So likewise only, I have calculated all the expected value for all the number of heads based on this observed values. This is the expected value. So can you understand how we calculate the expected value now? And then next you have to put all those things in the table. So this table shows number of hits, observed value, and expected value. So now we have using this formula and how to calculate this expected value, you know that. And then you have to make 0 OI minus, that is observed value minus expected value, and that square of this, and then OI minus EI the whole square dividing by AI. That means this value dividing by the corresponding EI, that is 10. Here 25 dividing by 50, and 225 dividing by 100. Likewise, you have to calculate all the values and total, that is sum. So after that, you have to put to the table. So this value is called the chi-square calculated. And what is the degrees of freedom? We have how many samples? Zero head, 1, 2, that is 0, 1, 2, 3, 4, 5. That is totally 6 values they have given. So by n minus 1, that is 6 values minus 1, so 5. So degrees of freedom is equal to 5. And you have to check in the table 5% level of confidence. So that gives 11.07. That is our calculated table value is of for degrees of freedom is 5, and the 5% level, the value is 11.07. So calculated value is greater than the table value. So our hypothesis is rejected. That means there is a significance of a coin, or the coin is biased. That's it. Okay, so just to remember that if the calculated value is greater than table value means our hypothesis is rejected, and calculated value is less than the table value, our hypothesis is accepted. Clear? So shall we move on to the next topic? So that is our independence of attributes. These are also very important. So here they have given one data. Here they have given a last sample goodness of fit, they have given a one single data. Here they have given a two data. So chi-square test the independence of attributes. So here we have assumed that the attributes A and B, the two sets of independent variables are given, and the expected frequency of each cell. So we have to mention here the cell values or cell place of the cell, and will be calculated using the formula. This is the formula for expected value. So the position of the cell and the corresponding total row total into column total dividing by the grand total. So this is a formula for finding the expected value for the given cell. So likewise you have to find. After that, the same formula can be written as a cell like that. And the degrees of freedom is equal to, there are two data, that is row wise one data, another one is in the column wise data. So these are called R minus 1. The column I mentioned here is S. So you can use C, that is no problem. So C is the column minus 1. So R minus 1 in C minus 1 is the degrees of freedom for the problem. So we move on to the problem now. So this is the first problem. The following table gives the classification of 100 workers according to sex and nature of works. So given using chi-square test, examine whether the nature of work is independent of the sex of the workers. So ஒரு workersக்கும் அந்த அவங்களோட genderக்கும் is there any relevant data or not? We have to check that only. So they have given a male and skilled, unskilled, female, skilled and unskilled, the total. So here this one is mistake. So this is 20. So here is 20. So just to change it. Wrongly I wrote as 30. Total everything is okay. That place only is 20. Okay. So now we have to find the corresponding. So these are all the observed value. These 4 values. So this 4 data, okay, you have to find the observed. These are all the called the observed value. These are all the total. This is row total. This is column total. And the last one is called grand total. So for this observed value, the corresponding row total is 60 and the corresponding column total is 50 dividing by the grand total, that is 60 into 50 dividing by 100. That gives the expected value for the observed value this. Likewise, you have to find for this means the corresponding row is 60 and the column is 50. So 60 into 50 dividing by 100. Likewise, you have to find the expected for this. So now we have found this. So E1 mention is male skilled. E2 is male unskilled. So I calculated this 2 is a row wise calculation. And then E3, E4 is the next row. So this is the first row and this is the second row. Okay. So after calculation, I put in the table like male skilled, male unskilled, female skilled, female unskilled. This is the observation observed data given in the problem, and these are the expected value we have calculated, and then the difference and square of this, and then this difference and the division of this. So it gives sum of this is equal to 16.67 and the calculated value is 16.67. So you have to check the degrees of freedom. What is our degrees of freedom? We have 2 rows. So 2 R minus 1 is 2 minus 1. And the how many columns? We have 2 columns. So C minus 1 is equal to 2 minus 1. So this one is 1 into 1. That gives 1. So pi square, we have to check in the table 1 degrees of freedom and 5% level. The table value is 3.841. So our calculated value is higher than the table value. So that in this 5% level of significance, this null hypothesis is rejected. That means we conclude that the nature of work is depend on the sex or gender. Okay, is it clear? And one more problem. From the following data, find whether there is any significant liking in the habit of taking soft drinks among the categories of employees. So they have given some different type of employees. One is clerk, teachers, and officers. And the soft drinks like Pepsi, Thumbs Up, Bovento, like that. The row wise total and column wise total. Here they have 3 attributes: row wise 3 attributes, column wise 3 attributes. So our hypothesis is fixing, and instead of using the software and employees, I put some shortcut, that is soft drinks I mention as A1, A2, A3, and the employees I mention as B1, B2, B3 respectively. So for the position A1, B1, that is soft drinks of first row, this 3 as a first row and columns. So observed value, you have to find the calculated. What is our calculated value? How we can find the calculated value? The corresponding total for this, the corresponding total into the row total into column total dividing by the grand total. That is the formula. So using that formula only, I have calculated this EI. And for this, from this, I can easily calculated y minus EI the whole square. And then the value is divided by EI. The last column is given. And the sum of this column is 60.23. Okay. So calculated value is 60.23. What is our degrees of freedom? So there are three rows. So 3 minus 1. And there are three columns. So 3 minus 1. So 2 into 2, that is, this gives 2 into 2, that is 2 into 2, 4. So you have to check in the table 4 degrees of freedom and 5% level of confidence. So the table value is 9.48. But in our calculation, it gives 60.23. So calculated value is higher than the table value. Here also our hypothesis rejected. Clear? So do it in yourself. So you have to check this. Here they have given 4 categories: below average, average, above average, genius, and some X or Y. X means boys, girls. We have kept this. So for this, how to calculate the expected value? The corresponding total 200 into 126 dividing by the grand total, that gives a 200, I think. 300. So likewise, you have to find the expected value and then you have to put. And what is the degrees of freedom of this? 4 minus 1, 2 minus 1 into 4 minus 1. This 2 minus 1 is 1, 2 minus 1 into 4 minus 1. That means 4. 3. 4 minus 1. Okay. So this is 3 and this is 1. 1 into 3 is 3. So you have to check in the degrees of freedom is 3 at a 5% level or 99, 1% level, whatever it is, you have to check with yourself. Okay. Thank you.